Welcome to The Explainer. Today we're looking at a pretty fascinating intersection between strict academic discipline and creative problem solving. We're talking about the Cambridge AS and A-Level Mathematics 9709 syllabus. It turns out, if you want to master the really tricky world of algebra, specifically modulus functions and inequalities, you have to learn how to improvise within a very strict structure. Think of it exactly like being a master jazz musician. You have to deeply understand and respect the foundational rules before you can get up on stage and flawlessly improvise.
So, let's dive right into the absolute most critical question here. Why are so many candidates missing really straightforward marks on these exact topics? Because, let's face it, there's literally nothing worse than walking out of an exam hall feeling like a total genius only to realize later that you dropped vital points on modulus functions. We have to figure out the disconnect between knowing the math perfectly in your head and actually scoring the marks on the paper.
Listen, the secret to saving your grade lies in what we call the method mark strategy. This is a fundamental grading reality in Cambridge mathematics. The process matters just as much as the final answer. The examiners, they aren't just scanning for a correct number at the very bottom of the page. They are actively looking for a transparent, logical trail of evidence that proves exactly how you got there. Method marks are absolutely your best friend on this exam.
So here's our roadmap for today to help you secure those marks. We are going to cover the modulus mark trap, the core principles, the standardized sequence, the top examiner warnings, and finally, that method mark strategy.
All right, starting with Section 1, the modulus mark trap and why raw math facts just aren't enough.
The examiner reports actually show a super sharp contrast here. Average candidates tend to rely on superficial breadth. You know the type. They scribble down a really messy mental calculation and just rush straight to the final answer. But top-scoring candidates, they treat every single equation like it's a case study. They build a machine of logic. They're actively questioning assumptions, applying systematic analysis, and justifying their decisions with hard evidence. They don't just calculate things, they prove them. Moving right along to Section 2, Core Principles and Framework, this is where we learn to improvise within that structure.
So the 9709 syllabus has this strict hierarchy of reasoning that you need to be aware of. At the foundational level, you have descriptive reasoning. That's basically just extracting data from the prompt. Moving up a tier, the analytical level requires systematic analysis using very clear notation. And then the gold standard is the evaluative level. This is exactly where examiners expect you to evaluate alternative approaches, compare them, and explicitly justify your recommendations.
And that brings us to what the syllabus calls a connected conceptual understanding. This goes right back to that jazz musician analogy from earlier. When you truly master these fundamental mathematical principles, you aren't just memorizing a list of steps anymore. You're suddenly able to seamlessly transfer and apply your knowledge to completely unfamiliar, highly complex contexts. You know the underlying rhythm of the math so well that literally no unexpected variable can throw you off beat. Okay, Section 3, the standardized sequence. Let's look at the examiner's procedural framework.
To totally master these modulus equations and inequalities, you have to strictly follow this 5-step standardized sequence every single time. First, deconstruct the question to identify the key elements. Second, apply your relevant analytical framework. Third, execute your analysis with incredibly clear working. Fourth, verify your results. And fifth, present them in the proper format. If you skip a step here, you are going to bleed marks. It's that simple.
And honestly, execution is only half the battle. Presenting your information using strict presentation conventions is what ultimately locks those marks in for good. The syllabus actually mandates proper headings, correct mathematical terminology, appropriate formats, and clear, structured annotations. Your exam paper absolutely should not look like a chaotic, panicked scratch pad, okay? It needs to look like a professional, polished, analytical report. Let's pivot to Section 4, Top 3 Examiner Warnings. This is high-value intelligence pulled straight from the principal examiner reports. According to the grading data across countless past papers, there are exactly 3 major traps where students consistently and needlessly lose their hard-earned marks on algebra and modulus function questions. Make absolutely sure you aren't making these 3 mistakes. First, the classic trap, applying the wrong analytical approach for the specific context of the inequality or equation. Second, completely forgetting all those strict format and presentation rules we literally just talked about. And third, providing generic final answers that failed to address the specific context given to you in the original question prompt.
Finally, Section 5, the method mark strategy, securing every possible mark through structured reasoning.
Guys, this is literally an urgent alert directly from the examiners. Students lose massive amounts of marks simply by not showing their working. It is the ultimate safety net. Even if you make a silly arithmetic error and your final numerical answer is completely 100% wrong, systemically showing your analytical process guarantees you pick up method marks. It can entirely save your grade.
So how do you actually show that evaluative thinking to get those marks? Well, your written working must demonstrate deep evaluative thought. You do this by explicitly questioning assumptions, by considering alternative interpretations, which, by the way, is incredibly important when you're dealing with the dual nature of modulus functions, by justifying every single step with solid mathematical evidence, and finally, by identifying any potential limitations in your approach.
To wrap this all up, the evidence is incredibly clear. The process matters just as much as the final calculation. Knowing this, are you going to keep rushing to the final number and bleeding points? Or will you step back, learn the rules, and become that structured jazz musician who secures every single mark available? Something to think about next time you sit down for a past paper. Thanks for exploring this with us.